So hello friends, today we are going to see actual numericals on design of Cotter joint. Up till now we have seen the design procedure of Cotter joint. So I will request all of you to note down all these design procedure, these 9 to 10 points on your notebook somewhere. And while solving numerical, we have to take the help of all these design procedure, formulas and equations. So you can pause this video, you can write down all the uh, formulas of the design procedure of the Cotter joint. Okay, and we are going to follow the same design procedure, and from where these formulas are obtained, from the failure chart we have obtained all these formulas. Okay, so let us start with the numericals now. So numerical of Cotter joint, what is the statement? It is required to design a Cotter joint to connect two steel rods of equal diameter. Each rod is subjected to an axial tensile force of 50 kN. Design the joint and specify its main dimensions. The material of the two rods and the cotter is selected as plain carbon steel of grade 30C8 with SYT, that is yield tensile strength or yield strength, is equal to 400 Newton per mm square. The factor of safety of the rods and spigot end, the factor of safety for the rods, spigot end and socket end is assumed as 6, while for cotter it is taken as 4. So whatever may be the problem, first of all we have to write down the given data. So first of all, first step is write down given data. So it is acting under tensile force, so tensile force is equal to 50 kilonewton. Then SYT is 400 Newton per mm square for all spigot, socket, rod and cotter. Sometime material of the cotter is different, material of socket is different, material of spigot is different, but generally the material of all these three is kept same. If it is different, then for socket material will be different, so material properties will be different, like SYT, SUT, whatever it is. Then factor of safety of rods is equal to 6. That means factor of safety, whatever rods are there which are connected to spigot and socket, of which factor of safety is 6. Then factor of safety of the cotter is equal to 4. So here two different factor of safeties are there. Sometimes factor of safeties are same for socket, spigot, rod as well as cotter. Second step, calculate all permissible stresses. So which are permissible stresses? So the permissible stresses for rods, spigot end and socket ends are as follows. Okay, so the first one, so permissible stress we have to find. How much is the permissible stress? Sigma T is equal to S by T upon factor of safety, which is equal to 400 by 6. Next is sigma C, that is compressive stress or crushing stress, is equal to S by C upon factor of safety. So here sigma C is equal to S by C upon factor of safety. So here we don't know the value of S by C, that is yield compressive strength is not known to us, which is equal to twice of S by T. So compressive yield strength is twice the yield strength in the tension. So SYC is equal to twice of SYT, which is equal to 2 into 400 by 6, as factor of safety for socket, spigot and rod ends is 6. That's why it is 6. So which is equal to 133.33 Newton per mm square. Next, shear stress. So shear stress is equal to yield strength in shear upon factor of safety, but we don't know the value of yield strength in shear, which is equal to 0.5 times S by T. So yield shear strength is equal to half of the yield tensile strength, which is equal to 0.5 into 400 by 6, which is 33 Newton per mm square. So these are the permissible stresses for rods, spigot end and socket end. Now permissible stresses for cotter. So first one is sigma T is equal to S by T upon factor of safety, which is 4 now. Factor of safety here it is 4, which is equal to 100 Newton per mm square. Shear stress is equal to SSY upon factor of safety. Again SSY is not known to us. We know the value of SSY, that is SSY is equal to 0.5 US by T upon factor of safety, which is equal to 50 Newton per meter square. After calculating permissible stresses, we have to go for calculation of dimensions. So here we are going to follow design procedure now. Okay, so what is the diameter of rod? D is equal to under root 4p upon pi sigma t. If we put the value 4p, 50 kilonewton, that is 50 into 10 raised to 3 divided by pi into 66.67, so diameter is equal to 30.90, that is 32 mm. Okay, this we have calculated. Next is calculate thickness of cotter. So thickness of cotter is T is equal to 0.31 D. So again I repeat, you keep your all list of formulas ready with you. You can actually tally. After first of all we calculated rod diameter using tension. Then second we are calculating now cotter thickness. Cotter thickness is T is equal to 0.31 times D. That is 9.92, or we can consider it as 10 mm. Then diameter of spigot. So spigot diameter D2 can be found. P is equal to pi by 4 D2 square minus D2 into T. So if we put the value of P, then pi by 4 into D2 into 10 into 66.67. So for spigot, what is sigma T? Sigma T is equal to 66.67. We already calculated as a permissible stress. Now here D2 square minus D2, if I simplify this equation, then I am getting this quadratic equation as D2 square minus 12.73 D2 minus 954.88 is equal to 0. Okay, so here I can recommend you that you keep your calculators ready. Along with this, you can pause it and then you can calculate the values. Okay, so I am getting this D2 square minus 12.73 D2 minus 954.88. Again, if I solve this, I am getting D2 is equal to 37.91 and another negative value. Negative value you can remove and you can keep only positive value. And D2 is equal to now 40 mm. Outer diameter of the socket. So what is the outer diameter of the socket? Formula that can be found with the help of tensile stress. That is P is equal to pi by 4 D1 square minus D2 square minus D1 minus D2 into T into sigma T. So put the value of D2 and get the value of D1 now. Only unknown is D1 here. Again we are getting quadratic equation. If we simplify this quadratic equation and solve it, we are getting D1 is equal to 52.04 or 55 mm. The next is diameter of spigot collar D3 and socket collar D4. So D3 is equal to 1.5 times diameter D, so 1.5 into 32, which is 48 mm, and D4 is equal to 2.4 times diameter, that is 76.8 or 80 mm. Dimensions A and C. A is equal to C is equal to 0.75 D, which is equal to 0.75 into 32, which is 24 mm. Then width of cotter. B is equal to P upon 2 tau L, 2 tau into T. Okay, so P and 2 tau T for cotter we have kept. So first one is P is equal to 50, then 2 into 50 into 10, which is 50 mm. So width I am getting 50 mm. Now width can be calculated by two ways. One is by shear stress, another by bending stress. So if I put the values here, B is equal to 3P upon T sigma B. Sigma B value is nothing but sigma T for the cotter. So what is the sigma T for the cotter? 100 Newton per mm square. This is very important thing. That is B is equal to under root 3P upon T sigma B. Sigma B is bending strength. That we have now calculated as a permissible stress. We calculated sigma T as a permissible stress for cotter joint. So sigma T is equal to sigma B, and if we put all this value, we are getting B is equal to 50 mm. So by both ways, by shear as well as by bending, we are getting B is equal to 50 mm. If we are not getting same, then whichever is the higher value, that we have to consider. So that if we are taking higher value in suppose shear strength, then it will not fail in shear as well as it will not fail in bending also. Okay, now checking for crushing and shear stress. See, up till now we have calculated all dimensions, but whether those dimensions are safe or not, that we need to find. So for that purpose, we have to go for the check. First is check for crushing and shear stress in spigot and Okay, so sigma c is equal to p upon t d2, which is equal to 15 to 10 raised to 3 upon 10 into 40, which is equal to 125 Newton per mm square, and tau is equal to p upon 2a d2, which is equal to 26.04. Sigma c, if we see, which is 125, and what is our permissible for socket, then for rod and for spigot it is 133.33. So sigma c here, how much I am getting? 125, which is less than permissible shear strength, permissible compressive strength, crushing strength, that is 133.33 Newton per mm square, and tau is equal to, tau must be less than 33.33, which is I am getting here 26.04. So my design is safe. Okay, now the check for crushing and shear stress in socket. This is for spigot. You can mention here spigot, I forgot to write it here, spigot. You mention spigot here. Now check for crushing and shear stresses in socket end. So what about socket end now? Sigma c is equal to p upon d4 minus d2 into t, which is equal to 15 to 10 raised to 3. So I am getting 125. Next, tau is equal to p upon 2 d4 minus d2 into c. So I am getting this 26.04. Okay, so here again sigma c is less than 133.33 and tau is less than 33.33. So shear stresses induced in these spigot end and socket end are less than permissible stresses. So our design is safe. The stresses induced in spigot and socket ends are within limits. That's why our design is safe. So next, thickness of spigot collar. So thickness of spigot collar T1 is equal to 0.45 times D, which is equal to 0.45 into 32, that is 14.4 or 15. And the taper of the cotter is 1 in 32. Okay, so let us start with the dimension sketch of cotter joint. Okay, so if I see now what are the dimensions here, so whatever dimensions we obtain, we are simply putting it. So this will be a front view, the top view will be there, and there will be a side view. So this is simple numerical of the cotter joint. For this you have to follow the design procedure. Okay, then stepwise solution we have to obtain. This numerical can directly ask for the 10 mark. So again my suggestion will be, you make a list of all formulas somewhere and you keep it in memory. You will have to mug it up so that you can recall it at the time of examination. Thank you.